Hi everyone, I'm Megan and welcome back to another lab video for Analytics and Decision Sciences 4293 Professional Analytics. In this lab, we will be exploring arrays in Excel VBA. If you like the contents of this video, please make sure you like, comment, as well as subscribe to our channel. The material presented in this lab will be based on VBA for Modelers, the 5th edition by Christian Albright, and Ivey case 9B11E022 by Wei Zia, which you can find on Ivey cases through the link provided below. Please open Excel and follow along as we get started.
An array is a group of variables with the same data type and name. If we have a list of items that are of similar type to deal with, we can declare an array of variables instead of using a variable for each item. For example, if we have 3 names, we can declare an array of variables instead of declaring 3 variables. There are 2 basic types of arrays, a static array and a dynamic array. In a static array, the size is fixed when it is declared, whereas in a dynamic array, the size is not fixed and can be changed later. First, we will talk about declaring static arrays in Excel VBA. For a one-dimensional array, we declare it as follows. So we use the dimension, or dim, and then we give the array name, the index, and as the data type we are using. So for any array, the index is the number of variables or number of data that we have in the array plus 1 because the index starts at 0. So if we have 4 here, we actually have 5 slots for data to go into rather than 4. We can also declare it as dim array name and then first index to last index. So if we do 0 to 4 in this case, that's the same as just writing the top one 4, like the top one with the index of 4, sorry. And then we have to also write as the data type. So the data type can be an integer, it can be single, double, or any other data types that you can have. One-dimensional arrays should be used when you have a vector that you need to store, but if you have a matrix, then you have to use a two-dimensional array. So to declare a two-dimensional array, we do the following. We first write dim, then the array name, and just like the first example that we did with a one-dimensional array, we put the index 1, and then because this is a two-dimensional array, we need 2 indexes, so we also have index 2. And then we add the as data type. So for this array, the two-dimensional array, the first index denotes the number of rows. We have to remember that we start at an index of 0. So whatever number we put there, we have to add 1, and that's how many rows will be in the array. And then index 2 is our columns. So same type of thing here. If we have, say, 3 columns, we need to write the number 2 here instead of 3 because we're starting at an index of 0. So we can also write it in the opposite way. So if we do dim array name 0 to, or sorry, I'll write it this way. First index 1 to last index 1. Then we use the comma again and we write first index 2 to last index 2. And then as data type. So when we're doing this one, it's the same idea as the second example of the one-dimensional array. So if we're going to use numbers in there, we can do dim array name. Say we'll do 0 to 4, which means that we're going to have 5 rows. And then if we do 0 to 10, we're going to have 11 columns and then as our data type.
Now you're probably wondering, why should we use arrays? Since arrays keep a list of variables in the same data type and name, they can make the code clearer and more efficient. It also takes less time to execute code when arrays are used and a lot of data is being processed. For a dynamic array, we do not need to declare the size of the array. This is useful if you don't know how many elements will be in an array. So to declare a dynamic array, we write the following. So we do dim array name, and then we do not need to write the index since we don't know how big or small it's going to be, and then as data type. So now that we've talked about static and dynamic arrays, we're going to go into an example. So before I do that, I'm just going to delete the information that I wrote here just as an example and to allow you guys to see what I was talking about.
So for this example, I'm just going to create an array and put some values inside of it. The values I'm going to put inside of it are going to be I squared, and we're going to count from I equals 1 all the way up until a specified number, which for this example is going to be 10. So first I'm just going to create our macro, which is going to be called array example, and then end it. So the first thing we need to do is we need to declare our array. So here I'm just going to make it a dynamic array, and it's just going to take on integer values. And then I also need to declare a counter, which I'm going to call I. So we're going to use I within our loop statement that we're going to write to give the values to put inside of this array. So this is also going to be an integer. So now I'm going to redeclare the size of the dynamic variable. So we're going to make it static. So for this example, I'm just going to let's use 10. And that's still going to be an integer. So since I did not declare anything as a base here, the score is going to have an index from 0 to 10, which means that there are actually 11 values within this array. So now we're going to do for I is equal to 1 to 11. So I'm using 11 here instead of 10 because, as I just said, there are actually 11 values that we can put inside of this array rather than just 10 because it starts at an index of 0. So now I'm going to close our loop. So as I said before, our index starts at 0, so that's what we need to account for. So if we do I minus 1, we're going to start at 0 and go all the way up until 10, which will fill the entire score function. So we're going to let this equal to I squared, just something nice and easy. So, and then I'm also going to put these values in cells A and I. So what does that mean? You're probably wondering. We're going to put them in A1 is going to be the index of 0, and then A2 is going to be the index of 1, and so forth. So then we need to write that as score I minus 1. So now I'm going to run this macro, and we will see the score array be put into column A. So after running that, over on the left here, we can see that at an index of 0, the value is 1 squared, which is what we expected, and then at an index of 1, the value is 2 squared, and so forth. So now what I'm going to do is I'm going to redeclare the size of the dynamic array that we created in this macro. So if I change it to 20 and keep everything the same, I'm just going to delete the outputs that we had when running the macro the first time. So if we run this again, we can see that only the first 11 values of this array are inputted, but we could go all the way up to 21, since there are 21 values in the score array, and that will work all the way up until cell A21. Now we can also do the same thing with a two-dimensional array. So to do that, I'm just going to get rid of our redeclaring the dynamic array, and I'm going to make our array static from the beginning. So we'll do 20 again, as that was the last thing that we did. So we'll have 20 rows, and then we'll have 21 rows, my bad, because we started an index of 0. And then if we input 3 here, we'll actually have 4 columns, because again, we start at an index of 0. And then I'm also just going to declare j as an integer as well. So we'll do for I is equal to 1 to 21, or we can go actually 0 to 20. That might be a little bit easier. And then we'll do for j is equal to 0 to 3. We'll write the score of I comma j is going to be equal to I times j. And then we'll let the range of A1, and then we'll select that, and using the selection object, we will offset it I minus, actually no, we can just use I because we're starting at 0. So I rows and j columns, and let that value equal to score I comma j. So we can get rid of what we did last time in that example, and then we need to close the j loop, and the I loop is already closed. So I'm just going to quick delete the work we did last time over here on the left, and we will run this macro, and as you can see, we get a 4x21 matrix. So if we quick look at row 1 here, we have I is equal to 0, therefore anything times 0 is going to be 0, which denotes these 4 outputs. If we move on to row 2, we are now looking at a value of I is equal to 1. So we have 1 times 0, 1 times 1, 1 times 2, and 1 times 3. Then if we move on to the third row, where we have an index of 2 for I, then we have 2 times 0, 2 times 1, 2 times 2, and 2 times 3, and then so forth all the way down. So if we just want to find what one value is of the array, I'm just going to comment out these 2 lines here because we no longer need them. So if we create a message box and say we want to find the score of index 11 for the rows and index 2 for the columns, we can run that and we get a value of 22, which if we go back to our matrix over here on the left, that is going to be row 12, which denotes an index of 11 for the rows, and column C, which denotes an index of 2 for the columns. And if you meet these up, it's going to be 22. So that is how you just extract one value from a two-dimensional array. So that's all the information I have for you for both one-dimensional arrays and two-dimensional arrays, as well as static and dynamic arrays.
This is all the material I have regarding arrays and VBA. I hope you found the contents of this video helpful when using Excel and VBA for decision modeling. If you like this video, please make sure you like, comment, as well as subscribe to our channel. If you are interested in more videos, please check out our playlist where we describe other ways to use VBA. Thanks for watching. Bye.